Well, hello. Thank you very much for visiting. And in the next few minutes, I'm going to be talking about a dream of a company that I call Sunbustion that manufactures solar smelter technology. Basically, what I'm doing here is bringing the surface temperature of the sun to all of mankind. When you take a magnifying glass out and focus the sun's rays onto a leaf or something like that, you're actually turning out the surface temperature of the sun, which is like 8,000 degrees. Build these things big enough, guess what? You can melt rock. So let me talk about a manufacturing plan for such a company here. Through these slides very quickly, but basically the logo here says bringing the sun to earth so that mankind can actually melt rocks and process steam and high temperatures and their own batteries. So here it is, our mission to build the best and finest and most cost-effective solar smelter technology and to solve global warming. We're talking about making our own Sunbustion. The goal is to reach out to those in poverty so they can create their own energy. So we're actually giving people who don't have energy. So this will be a for-profit OEM manufacturing company. And what I want to do is make kits, box them up and sell them on, say, Amazon. So anyway, one of the best materials is aluminum. I'm going to come in with standard sizes of the various designs. 4 feet in diameter, 12 feet in diameter, and even on up to 12. If you build these things big enough, like several thousand feet, you could actually create solid light. Oh boy. So anyway, what I want to do is to turn out factories and make kits and then put them in shipping containers 8 feet by 8 feet by 20 feet and ship around. So basically, it is proposed that all aluminum version of the solar smelter be mass produced. It's recommended the solar smelter be 14 feet, but it can be other dimensions too. And also overhangs. There are different designs. And basically what happens is the sunlight goes into the parabolic, as a half-shell parabolic or paraboloid, and focuses. This is a solar cooking version. And you see that this is a laser test. We're trying to perfect it. The surface, I'm using aluminum mylar here, but really what we need to do is go to electroplating process. My experience, they use silver aluminum oxide using electroplating process. So anyway, we've done different designs. Make it boxable, make it skittable, make it. This is just very different sheet metal I have here. Solar smelter can potentially bring the surface temperature of the sun to the common man without using fossil fuels. We are making, well, basically we can even make lava, with constant light. By making the parabolic shell is actually a very difficult thing, but there are several different ways of doing this. Spun aluminum, vacuum stamping, roll forming, 3D primers. The thing to do is come up with a machine shop process where you just use common sheet metal and things. And we can make and things. This is a spun aluminum process where we basically put it on a big machine, then it spins around spun. You have a whole bunch of, then you send it into electric and make it really reflective. Our experience is that silver, right now we're using silver mylar, and it's not good enough. But my experience, really what we need to do is electroplate silver and then put a layer of aluminum oxide across the top. 4-foot version is 4,000, 8-foot is about 8,000, and 12-foot is about 12,000 BTU. And so, electroplating is really the best way to go. You can make these thick, and then you put an insert. We won't make the bricks in the state of Washington to ship the bricks to Afghanistan. No, what we do is make the bricks in Afghanistan, then ship the components for making it. Basically, this is a tracking version, where the heliostat tracks tracks the sun, and then puts the sunlight into the parabolic. And then we have a mask, and that thermal mask made out of bricks. And all kinds of things we can do. Put salt in there, use recycled materials to make glass. Anyway, these bricks get hot, and then they transfer the heat to embedded pipes, and the pipes make hot air liquids. Of ways of doing this. You build this thing big enough, oh man, float it on a turntable, it floats in. Jesus, I mean, this is big. This is a patented solar. They are patented. Solar smelter technology is the use of concentrated sunlight to make useful heat. The market for solar thermal technology is bigger than photovoltaics. Hot water distillers, coal-burning power plants with this kind of technology. The market is huge. There is a prospectus at Bank on IP in Stillwell, Kansas, had done a prospectus on it. Himen Corporation of China has done extensive manufacturing analysis and are prepared to go in mass production. All this, by the way, has been intellectual property has been donated to Solar Cookers International. The market for solar smelter is just as big as petroleum, coal, gas, or nuclear. It can power the entire planet. My application, this is huge. This is a assemblable version that is based on bicycle wheels. I call it sunbusting. I'd actually figure out that total cost. We've got to do the engineering. This is about as complicated as building a Tesla. So we have to do the engineering before we can actually come up with the cost. But the market, the invention, this is one brick. This is a bicycle shell. And then one version that was actually done by Native Americans. They just carved parabolics in the cliffs, wait till the sun swung around, and then they were able to melt gold. They used gold as reflection surface. In ancient time, the Egyptians used to make them out of copper, electroplated silver, copper and electroplated silver, and then they put gold across the top of the silver to keep it from tarnishing it. Package these things. Now here's a really nifty design. This is a solar picnic table. Been known to turn out turkeys to serve them at midnight. This right here is the solar wedge cooker. We make them out of political campaign signs, recycled. And this right here is an example of an all aluminum version, a really big one. We made biodiesel fuel for city transit bus design. You can use glow rocks to make light. Ancient Egyptians didn't, when they went inside the pyramids, they didn't use light bulbs or torches. They had glow rocks. These are rocks that glow after you get sunlight. You can hook these things up to coal-burning power plants. You can burn them to solar. All kinds of ways of doing this: hot air, make hydrogen, all the things. But the technology there for gritting. And whatever it is, you want to make sure these are common. So the one manufacturing process, so you can have a flexible tooling line, so you turn out one version on Monday, another version on Tuesday, and come in. The strategy is to mass produce these things, fix it up so that it's cheap, low cost, and affordable by anybody, and protect our proprietary information. Location analysis. Best place to make it: British Columbia, Washington State, China, Iceland, wherever there's cheap hydroelectric power. Eventually, we want to be able to use heliohydroelectric, which is a form of solar energy that makes hot air, and makes electricity. The solar smelter technology has the potential of providing all the energy of the world's needs 24 hours a day, year round. The game plan and the goal is to produce one unit, make a lot of them. And of course, we're going to have to do trade engineering studies to figure out the exact cost of manufacturing, because we had to design a lot of machinery. The Congo, by the way, I've been in contact with Congo. They are very interested in doing solar mining because they have a lot of rare metals there. The market of solar smelters has got to be in the trillions of dollars. So therefore, that's just a quick overview of what the company Sunbustion would look like. I'd like to thank you very much for all your attention on the matter. Just give it some thought. And I'd like to see investment capital opening up. I'd like to see us making it in the United States for a change instead of having to go to China or Europe. Bye-bye.